Hey everybody, just a short video to show you guys how to use a thing called the Freeform graph generator. Now what this graph generator does is it gives you the ability to draw graphs that are not pre-specified. So in the previous examples, you for instance had to do a depth first search from an existing graph, or a breadth first search from an existing graph, or a minimum weighted spanning tree from an existing graph. And the problem with all of that is that it was from an existing graph. Now, we've also deployed something called the Freeform graph generator, which you can find at lamp.ms.fits.ac.za/graphs/freeform.html. That link is on the Moodle page. And with this graph generator, you can work on free-form questions, right? And one way that this will be used in the course is I've been talking a lot about the fact that graphs can be used to solve problems, and you've seen some of it in your quizzes, but you weren't really asked to deal with it in depth. Um, so what this graph generator allows us to do is to check and to see if you guys understand how to build these graphs from the questions. So what I'm going to go through in the video is just how this can be used. So the example I'm going to be using is a question that was in quiz 3, and it talks about a dinner party that's being held for old musicians. And it says that people who've left bands tend to have left bands because they don't like the people in those bands. Now, there's a musician getting married, and so you have to put these musicians at tables. But you have to put them at tables such that no two people who have been in a band together will end up at the same table. Okay? And the question you were asked in the quiz is, which algorithm would you use? So let me try and phrase this question differently. Basically, what we're trying to do is assign tables to musicians such that no musicians who've shared a band can get the same table. Okay. Now, if we just listen to that, it sounds almost the same as saying that we want to assign colors to vertices such that no um, adjacent vertices are assigned the same color. So the answer is that we'd like to use graph coloring. Okay. But it doesn't make sense to use graph coloring without a graph. So when we see a question like this, the first part of solving the problem is actually trying to convert it to a graph. Okay. So what we're going to do is we're going to draw the graph in this system. So the first thing we have to do is we have to do the question setup. Okay, so question title, I mean, you can write anything you want here, but I'll call it musicians maybe. And this graph will have to be colored because the problem is graph coloring. It's not directed because if our musicians were in a band together, if A was in a band with B, B will automatically be in a band with A. And it's not weighted because there's no like numerical values to the edges. So I say confirm, and I've got my question set up. Now, when I look at this problem, basically, I've got these people: Freddie, Kurt, Marilyn, James, Peter, Phil, and Joe, right? And what I want to do is I want to make sure that they're not assigned to the same table. So the first thing I'm going to do is I'm going to make vertices for these people. So I'm going to put F for Freddy. I'm not going to write Freddy because it's too long a word and it's going to be hard to read. So I'm going to say Freddy, Kurt, Marilyn, James, and Peter. Okay, so I've got a P for Peter, so I'm going to use H for Phil because I can't use P again. So Phil and Joe. Okay, so now I've got my vertices, and at the moment they all don't have colors, and that's fine. Okay, now let's say all I was asking you to do was to draw the graph, right? I'm not asking you to color it for now. I just want you to draw the graph. Then what you'd have to do is you'd have to say, well, under what circumstances do I want an edge between two vertices? Well, remember, an edge means that when I color the graph, the two won't be able to share a color, right? Now, what I know is that musicians who have been in a band together shouldn't share a table. So that means musicians who have been in a band together should share an edge, because that way the graph coloring algorithm won't allow them to share the same color or the same table if we use colors as tables. So then I see that Freddie, Kurt, and Marilyn were in a band called Backslash, which means that Freddie Kurt and Marilyn should have edges between them. In the graph drawing program, I can draw edges by holding the right mouse button and dragging it to the uh, target vertex, right? So I'm going to hold the right mouse button from F and drag it to K, and I get an edge, and from K to M. Okay, now there's edges between Freddy, Kurt, and Marilyn because they were members of Backslash. And the cool thing about that is graph coloring will make sure that Freddy, Kurt, and Marilyn are not allowed to have the same color or table. Next one is Freddy, James, and Peter were in a band. So Freddy, um, James. Did I put James twice? Ah, I think I did put James twice. Okay, so let me. Oh no, one of them is Joe. Bah. Okay, let's delete that one and then let's make a vertex for Joe, which I'll use the letter O. Okay, so to delete a vertex, I just clicked on it and pressed the delete key on my keyboard. So it was easy enough to do. And to add another vertex, I just, put the O and hit add vertex, and there it is. Okay, so Freddy, James, and Peter were in all caps. So that means Freddy needs an edge to James, Freddy needs an edge to Peter, and Peter needs an edge to James. So that means they now can't share a table. Then Phil and James used to be members of Transmission Control Protocol, which I think is a fantastic band name, by the way. So Phil, which is H, and James, which is J, were in a band, so they need an H. Okay. Then Joe, Phil, and Marilyn were in a band. So Joe, Phil, and Marilyn were in a band. Okay. And that band was called Convex Hull. And then Kurt, Phil, and Peter were in a band. So Kurt, Phil, and Peter were in a band. Okay. So this becomes the graph, and I can move the vertices around just so that it's easier for me to see the properties. But so this graph is then, the graph that represents the situation. So if I, for instance, asked you to produce a graph that represents the situation, not necessarily to color it, but just to create the graph, then you're now done. You've done that. So you can click download, and you'll see it produces a text file, graphmusicians.txt, right? And you can then put that txt file in your submission on Moodle. So, okay, for this question, there isn't a submission because this was just an example. But let's say that I was going to try and submit it to one of the other answers. Then I can um, let's say I wanted to submit it to question one. What I could do then is I can say, okay, edit submission, and now I don't want to put the file that was there, but I do want to upload this graph musicians, not the PNG file. Sorry, that's a mistake. I want to upload the text file, right? And then I'll upload it and save changes, and the marker will tell me if I'm correct. Okay. Now that's true for the labs, but in the exam, it won't. So in this case, it says the answer is incorrect, and that's because this question one is not this question, right? Question one is a completely different question listed up here. So, but that's the process. You just hit download, and when you download, you get a PNG file, which is an image of the graph you created, and a txt file, which is the sort of specification for the graph, and you upload the txt file as the answer. Okay, so there's two questions uploaded right now for you to try, and there'll be a couple more next week. Please do try and upload these questions because this is the submission system you'll be using for your exam. Okay, thank you very much.